Hello everyone, welcome to MK Academic Solution. In this video, I am going to explain about the rate expression or rate equation. Along with that, we will discuss about rate constant and order of reaction. Okay. So first of all, what is the rate law or rate expression? Okay, rate law or rate expression gives relation between rate of reaction and concentration of reactants. Okay, so here according to the rate law, rate of reaction is directly proportional to concentration to the power n. Okay. So here, according to rate law, rate of reaction is directly proportional to what? Concentration to the power n or partial to the power n. Okay, now here to remove this proportionality, we are going to keep a proportionality constant k and concentration to the power n. Okay. So here where k is called rate constant and n is called order of reaction, we will discuss later. Okay. So for example, let us take an hypothetical example. N moles of A plus m moles of B react together to produce product. Okay, one product here we are getting. So according to rate law, rate expression or rate equation, so rate is equal to k into a power x and b power y, which means here rate of reaction we can write by using experimental data only, but by not using balanced chemical equation. Okay, so here x and y may be equal to n and m, or may not be equal to x comma y, may not be equal to n comma m. Okay, so here rate of reaction or rate law we always write by using experimental data only, by using experimental data only, but by not seeing simply balanced chemical reaction. See, for example, one real example I am going to take here. So H2 plus I2 gives rise to 2HI. H2 plus I2 gives rise to 2HI. So here what are the coefficients 1 and 1? So here rate is equal to k into H2 to the power 1 and I2 to the power 1. Okay, and for suppose if I take one more reaction, 2N2O5 gives rise to sorry, not this reaction. You can take CHCl3. You can take this CHCl3 is gives rise to CHCl3 in presence of chlorine. Okay, or acetate like this. Okay, right. Okay, you take CHCl3 plus Cl2 is gives rise to CCl4 plus HCl. So for this reaction, if you write rate is equal to rate law for this rate is equal to K into CHCl3 power 1 and Cl2 power 1 by 2. Means here 1 is the stoichiometric coefficient of CHCl3, half is not the stoichiometric coefficient of Cl2. And you take one more example also. 2O3 is gives rise to 3O2. This is the decomposition of oxygen. If you take the decomposition of oxygen, rate is equal to K into O3 power 1, sorry, O3 power 2, O2 power minus 1, O2 power minus 1. See here, sometimes here product also may involve in the rate expression or rate equation. Okay, that's why I told you the rate law we always write by using experimental data only, but not by seeing the balanced chemical equation. Okay, right. So this is about the rate law, rate expression or rate equation. And now let us see the rate constant. Okay, let us see rate constant. Rate constant. Okay, rate constant K. Okay. So here, what is the rate constant? When you write the rate law, rate is equal to K into concentration to the power n. So here K is called rate constant. Okay. So here what is K here? K is called rate constant. Rate constant or velocity constant. Velocity constant or specific rate of reaction. Specific rate of reaction. Specific rate of reaction. Specific rate of reaction. Okay. So here K is directly proportional to rate of reaction. K is directly proportional to rate, which means children here K increases, rate of reaction is also increases. K decreases, rate of reaction also decreases. Okay. And next let us see the units of K. Units. What are the units of K? Okay. Units of K. What are the units of K? So first you write the rate. Rate is equal to K into concentration to the power n we will take. So therefore K is equal to rate by concentration to the power n. Okay. So here what is the rate? See, for example, here we are going to take A is gives rise to product. A is gives rise to product. So here what is the rate? Here what is the rate? Rate is equal to minus dA by dt. Minus dA by dt. Okay, rate is equal to dA by dt. So here what are the units for rate we can write concentration by time or concentration into time inverse. Concentration into time inverse we can write. And here K is equal to, we know what is K is equal to rate by concentration to the power n. So what are the rate units here? Concentration into time inverse into concentration to the power minus n. Right, like that you can write. Okay. So now here K is equal to, okay, how we can write concentration to the power? Concentration to the power here nothing is there, means 1 concentration power 1 concentration power minus n, concentration power 1 minus n into t power minus 1, time inverse power minus time inverse. Okay. So now here what is the concentration? Generally we write concentration we can take as moles per liter or sometimes partial pressure also you can take. So here concentration what you can take? Moles per liter 1 minus n time inverse, or this we can write as mole power 1 minus n liter power n minus 1 time inverse. Like that you can write. This is the units of K. Or sometimes concentration we will take as the partial pressure. What is the partial pressure units? Generally we will take the atmosphere. Atmosphere to the power 1 minus n time inverse. Like that also you can take. Okay, these are the units of K. Okay, so if in place of n we can write any digit like 0, first order, second order, third order, like that. So you will see the units of nth order. So these are what? These are generally, these are what? Units of nth order. These are what? Units of K in nth order. Nth order. Units of K in the nth order. Okay. See, for example, if n is equal to 1, if n equal to 1 means that is first order. If n equal to 0, that is 0 order. Like that, if n equal to second order, if n is equal to 3, third order, like that. Okay. So we know what are the units of K. Units of K for nth order reactions. For nth order, what are the units of K for the nth order? So here K is equal to concentration to the power 1 minus n time inverse. For example, for 0 order, n equal to 1. For 0 order, n equal to 1. Therefore, here K is equal to concentration to the power, sorry, for 0 order n equal to 0, concentration to the power 1 minus 0 time inverse. Therefore, K is equal to concentration we can take as a moles per liter. Moles per liter to the power 1 time inverse. Or else we are going to take partial pressure, atmosphere to the power 1 time inverse. So these are the units of 0 order reactions. Next, if you take the first order reaction, take the first order reaction. So here what is the first order reaction? See, first order reactions. Okay. So first order reaction is n equal to 1. So then what are the units of K for the first order reaction? Okay, here K is equal to, we know, concentration to the power 1 minus n time inverse, and here n equal to 1. Therefore, K is equal to concentration to the power 1 minus 1 time inverse. Therefore, K is equal to concentration to the power 0 time inverse. Okay. So therefore concentration power 0 means 1 into time inverse. Simply for time inverse for the first order reaction, and the second order reaction also you can write like this. Okay, see for example second order reactions we are going to consider. Here n is equal to 2, therefore K is equal to concentration to the power 1 minus 2 time inverse, therefore K is equal to concentration to the power minus 1 time inverse. So in case of concentration you can take moles per liter or atmosphere. When you take atmosphere, when the concentration given in the partial pressure. Okay, so therefore K is equal to atmosphere to the power minus 1 time inverse, or K units is equal to moles per liter to the power minus 1 time inverse, or this we can write as mole power minus 1 liter power 1 time inverse. Like this we can write. So these are the units of K. Next, characteristics of K. What are the characteristics of K? Characteristics. What are the characteristics of K? Means the rate constant. Simply characteristics means K depends on. Simply the first one, it depends on temperature. For the same reaction, temperature changes. Rate constant also changes. Temperature, and second one, activation energy changes, rate constant also changes. And catalyst, it depends on catalyst. Rate constant depends on what, children? Catalyst also. In some the same reaction we are using catalyst and doing reaction, and we are not using catalyst and doing the reaction. Is K is having different values with catalyst and without catalyst. Okay, next, path of reaction. The same reaction can occur in different paths. Okay, so if it occur in different paths, it depends on the path of reaction. Okay, and nature of reactants. See here, reactants changes, K also changes. Means each and every reaction is have particular rate constant, and it is not a universal constant. It depends on what type of reaction. It is not universal constant. Universal constant depends on type of reaction. Next, K independence on concentration. Simply you can take here concentration of reactants. What is the concentration you take also, K is not at all going to depend on the concentration. Okay, this is about what? Rate of reaction and rate constant. Okay, next we will discuss about the order of reaction. Okay, children. So this in the next video I will explain you about the order of reaction and some previous year questions of order of reactions which are related to rate law, rate expression, and rate constant, and order of reaction. Okay, thank you for watching.